Welcome back to BAS 121. We're working on regression, chapter 9.13. And right now we're going to do example 9.13 in the book. Now, just like we did with all the other statistics, remember we had z-scores and t-scores, and then we had different stuff and different tools for categorical data. For example, for numerical, we had the ANOVA test, and then for categorical, we use chi-squared. Well, now we've got the same, a little bit of an issue with regression analysis, because if you think of a regression analysis, it uses numerical data. In fact, a couple examples back, the banking, if we included two columns of categorical data, we get an error statement. You can't have categorical data. So the trick we use to get around that is we use what's called dummy variables for categorical data. So in this example we were talking about, it asked us to go to the employee salary data. And here it is right here, the salaries, the age, and whether they have an MBA or not. Now obviously this is categorical data right here. Now what we did to convert this to numerical data is we just assigned a number to it. And I just said a yes is a 1 and a no is a 0. So I just put an if statement in here. It said if this column, D36, is yes, and of course I have to put it in quotes because it's categorical data. If that statement's true, then put a 1. Otherwise, put a 0. And then I just simply copied it all down and took a quick look to make sure my yeses were 1s and my nos were 0s. Now that I've converted all my raw data into numerical data, then it was just simply coming up here and going to data, data analysis, regression, filling out my fields for my y, my dependent variable, my x range for my two independent variables, telling it where I wanted to put the output, and it gave me the following output. Some important things, the adjusted R squared, very good, 0.94. Of course, if we get that high of an adjusted R squared, we almost certainly have a very high F statistic, and the significance of F, meaning again that my variables or my independent variables are doing a pretty good job of explaining my variance. And there you can see the coefficients in the p-values. All the p-values, with the exception of the y-intercept, which I can't do anything about. All my independent variables have p-values far, far, far less than 0.05. So we can go ahead and write our equation. The depends on how much you want to round here. My intercept plus my age coefficient times age plus my MBA coefficient times whether or not they have an MBA or not. So if you think about it, if MBA is 1 and not having 1 is 0, on average an MBA helps, according to this model data, helps your income by $14,767. So that's an example of how we can do regression analysis on categorical data. We basically convert the categorical data to numerical data, and then run our regression analysis as we would. And again, we have to check to make sure there's the p-values are right. We could also check to make sure that we don't have any multicollinearity, even though I would be surprised if we do, because age and MBA seem like two different things. That's it. Any questions, let me know.